We are now in our chapter 2, and this talks about the introduction to subsurface exploration. So now let's begin. The preliminary site exploration. So the designer of a superstructure foundation must perform a detailed surface and subsurface soil exploration of the potential site prior to deciding on the nature and the type of the foundation. This program for a given site should account for the type, size, and importance of the proposed structure. These parameters helps focus the design of the site exploration program by determining the quantity and the depth of soil soundings or borings required. Planning for a site investigation should also include the location of underground utilities such as phone, gas, and power. A local call before you dig service should be notified several days prior to the anticipated investigation. So these services are usually subsidized by the various local utilities and have no associated cost. So the next one is the subsurface exploration, and the testing specifically serve the following purposes. The first one is aid in the preliminary selection of substructure types that are viable for a particular site and the type of superstructure to be supported. Second, provide a basis for selecting soil and rock properties needed for substructure design. Third, identify special substructure conditions requiring special provisions to supplement standard construction specifications. So the following types of subsurface information are needed for the selection, design, and construction of substructures. The first one is the definition of soil rock stratum boundaries. Second, variation of groundwater table. Third, location of adequate foundation bearing layers. Fourth, magnitude of structure settlement and height. Fifth, dewatering requirements during construction. Sixth, potential problems including buildings, cracks, slope instability, etc. And lastly, the construction access. So there are two distinct phases exhaustive subsurface exploration. So the first one is the preliminary investigation. One would attempt to obtain as much valuable information about the site as possible with least expense. In this respect, a wealth of useful information can be collected using the following sources. So the first one is the topographic maps. It includes landforms, ground slopes and shapes, and stream location. The second one is the aerial photographs. It includes also the landforms, soil types, rock structure, and stream types. Third is the landforms and soil descriptions close to the ground surface. Fourth, well drilling logs. Fifth, existing boring logs. Sixth, local Department of Transportation soil manuals or DOT. Local U.S. Geological Surveys or USGS soil maps. 8. Local U.S. Army Corps of Engineers hydrological data. And 9. Local university research publications. So the second type of subsurface exploration is the detailed investigation. It has to be conducted at a given site only when that site has been chosen for the construction. Since the cost of such investigation is enormous, this stage of the investigation invariably involves heavy equipment or boring. Therefore, at first, it is important to set up a definitive plan for the investigation, especially in terms of the borehole layout and depth of boring at each location. As for depth of boring, one can use the following criteria. If the bedrock is in the vicinity, continue boring until a sound bedrock is reached, as verified from rock core samples. bedrock is unreachable, one can seek depth guidelines for specific buildings such as those given by the following expressions. So for the first one is for light steel and narrow concrete buildings. Second one is for the steel and wide concrete buildings. So if none of the above condition is applicable, one can explore up to a depth at which the foundation stress attenuation reduces the applied stress by 90%. So this is generally occurs around a depth of 2B, where B is the minimum foundation dimension. So next one is the soil boring. The quantity of boring is largely dependent on the overall acreage of the project. So the number of foundation or the intended use of the site for foundation, its depth of borings depend on the zone of soil influenced by the foundation geometry and the given loading. At the minimum, one boring should be performed at each pier location to a depth of 3 to 5 foundation diameters below the anticipated foundation. For extremely important structures, the designer or client not only requires more scrutiny from the subsurface investigation but also requires an amplification factor that can be applied to the load to assure a low probability of failures. In virtually all cases, depending on the type of design to be considered, the designer must recognize the effect of site variability as well as the type of testing that can be conducted to increase confidence and reduce the probability of failure. So this is our instrument. So the first one is the hand augers. It can be used for boring up to a depth of about 3 meters in a loose to moderately dense soil. So here's figure A is the hand augers. So in the figure B, which is the mechanized augers, it can be used in loose to medium dense sands or soft days. Next one is the dry sample boring. It is a type of boring when you brought a cut soil up to the surface. A technically qualified person should observe the texture, color, and the type of soil found at the different depths and prepare a borehole plug laying out soil types at different depths. So, a wash boring is carried out using a mechanized auger and a water circulation system that aids in cutting and drawing the cut material to the surface. This is the figure of a wash boring. Next is the situ or situ testing. It is the ultimate phase of site investigation where foundation design parameters can be evaluated to a relatively higher degree of reliability than under laboratory conditions. This is because the reliability and the accuracy of the design parameters obtained in the laboratory depend on the disturbances undergone by the retrieved samples during the retrieval, transport, extrusion, and sample preparation process. So the predominant factors causing soil sample disturbance are as follows. The first one is use of the samplers that have relatively high metal percentage in the cross section. So this is the formula for the area of ratio, where DO and DI are respectively the external and internal diameters of the sampler. For these samplers, the value of AR exceeds 100%. For friction between the internal sampler wall and the collective sample, causing a compression or shortening of the sample, this can be addressed by introducing a minute inward protrusion of the cutting edge of the sampler. Third one is the loosening of the sampler due to upheaval of roots, escape of entrapped air, etc. So this is the formula where the P and LR are the depth of penetration of the sampler and the length of collected sample. Furthermore, it is realized that LR values close to 100% indicate minimum sample disturbance. Fourth, lastly, the evaporation of moisture from the sample causing particle reorientation and change in density. This effect can be eliminated by wrapping and sealing the soil sample during transport to the testing laboratory. So, the meaning of site 2 or situ testing refers to those methods that evaluate the performance of a geotechnical structure or the properties of the soils or rock used to support that structure. So methods of site 2 evaluation can be invasive or non-invasive, destructive or non-destructive, and may or may not recover a specimen for visual confirmation or lab testing. So invasive tests tend to be more consuming, expensive, and precise, whereas non-invasive tests provide a large amount of information in a short period of time that is typically less quantifiable. So the geophysical methods is the ground penetrating radar is a geophysical exploration tool used to provide a graphical cross-section of subsurface conditions. This cross-sectional review is created from reflections of repeated short-duration electromagnetic or EM waves that are generated. So this information from GPR can be used to make a recommendation for more invasive techniques such as borings. So the figure below or the 2.4 figure shows a ground launch GPR systems being pushed along a predetermined transect line. So the GPR system comprises an antenna which services as put or transmitter and a receiver and a profiling recorder that processes the data and provides graphical display of the data. So now we are now in the resistivity test. So what is the resistivity test? Electrical resistivity imaging or ERI shown from the figure below is a geophysical method that maps the differences in the electrical properties of geologic materials. These changes in electrical properties can result from variations in lithology, water content, pore water chemistry, and presence of buried debris. The method involves transmitting an electric current into the ground between two electrodes and measuring the voltage between two other electrodes. So the seismic refraction is a technique that measures the seismic velocity of subsurface materials and models the depth to interfaces with a velocity increase. Soil conditions and geologic structure are inferred from the results, since changes in material type or soil conditions are often associated with changes in seismic velocity. So, seismic energy, which is introduced into the subsurface using a drop wave of explosive source, propagates through the earth as a wave from that is refracted by the material to which it passes. This is the model or a conceptual sketch of seismic refraction layout and wave path. So as illustrated in the above figure, the wave from front intersects a high velocity interface, creating a head wave that travels in the high velocity material nearly parallel to the interface. The energy the energy in this head wave leaves the interface and passes back through the low velocity materials to the surface. Geophones placed at selected intervals along the ground surface detect your or the ground motion and send an electrical signal via a cable to our recording seismograph. This test is used to determine the stratigraphy such as the depth of bedrock. It is best suited for stratigraphy that estimates increases estimate the bedmar in mapping faults and fractured rock zones, locate the water table and estimate material elastic properties such as the shear modulus position ratio. So the physical sampling and penetration test is a standard penetration test is or SPT is undoubtedly the most common method of soil exploration for foundation design. It is an invasive test that not only provides information from which soil strength can be estimated but also provides a physical sample that can be visually inspected or used for lab classification. The SPT is described by the American Society for Testing in Materials or ASTM as test number entitled Standard Methods for Penetration Test and the Split Barrel Sampling of Soils. So SPT correlations with shear strength properties. Correlation have been established that provide estimates of situ soil properties based on the soil type and blow count. The basic principles underlying the SPT test is the relation between the penetration resistance, shear strength of soil, which can be visualized as unique relationship. For instance, sands with identical structure which appear stronger or higher blow counts at greater depths than one at shallower depths, as such soil properties such as unit weight may be better estimated if overburden effects are removed or normalized. However, soil properties such as shear strength are available and bearing are enhanced by greater in situ stresses and are generally correlated to uncorrected blow counts. So the following expression is used to correct SPT and values by normalizing it as 95.5 kPa overburden in situ state. So this is the following expression used for SPT values, where N is the measured field SPT value, N is the SPT value corrected for overburn stress. So this is the formula or expression used to correct SPT N values. So efficiency of standard penetration testing is the actual energy affected in the driving of the SPT equipment varies due to many factors. Hence, in addition to the effective overburden stress at the tested location, the SPT parameter depends on the following conditional factors. The first one is the hammer efficiency. Second one is the length of drill rod. Third is sampler. Fourth is the bore hole diameter. So the following equation has been suggested for obtaining an appropriate standard SPT parameter to be used in foundation design. So this is the formula where E is the standard hammer efficiency equals 70% and is the SPT value corrected for the effective overburden stress and I are the factors that account for the variability due.
Good evening to all of us. Gampit gabi to holo na new. By the way, I am Jay Aloot, the second reporter in continuation of the in situ soil testing. I will be discussing the different types of soil testings. In situ rock testing. in situ rock tests are done to determine the stresses and deformation characteristic of rock and shear strength. So, kining rock testing, magamit ni siya to determine the stresses and deformation of any characteristic or the sizes of the rock or equality of the rock and to get the shear strength. So the purpose of this testing is to define the strength, bearing capacity, and stresses conditions. So in situ rock testing, there are three methods in rock testing. First is time drilling. With this method, the driller must record the time to advance a wash boring through the bearing stratum while maintaining a constant crowd pressure, fluid flow, and rotational bit speed. Bearing stratum underlying soil or rock that can bear the weight of a building. The second is coring method. It is to obtain an undisturbed intact sample representative of the in situ material. When designing from rock core samples, it is important to consider the factors affecting samples retrieval and hence their quality. So, magdepende gyud sa quality sa samples. Then, ang ikatulo, in situ rock strength test. Direct measurements of in situ band or shear strength of the drilled shaft to rock interface can be obtained through small-scale anchor and pull-out test or full load test. So magamit siya og anchor, small scale or full load test. Then, mato siya ang tulo ka methods in situ rock testing. So, drill core sample can be obtained from three different types of core barrel. The first one is single tube, the simplest type of coring barrel. See the figure 2.11. So, this is in situ rock coring apparatus. Ang A is a single tube and B double tube with rotating inner tube, and the C is double tube with a fixed inner tube. So mao ni siya ang makita diri sa figure 2.11 ang single tube ug ang double tube. So ang double tube is differ from single tube barrels by essentially isolating the drill core from flushing fluid. So see the figure 2.10. So, mo ni siya ang dagway sa double tube. So, naka-labeled sa 1 to 9. First is diamond bit, 2 core trap ring, and 3 core trap housing, and 4 caliber ring, 5 extension tube, 6 inner tube, and 7 outer tube, 8 ball bearing, and 9 is drill barrel head. So, mao ni siya ang iyahang naung or dagway sa double tube. Triple tube is essentially the same as double tube with a fixed inner tube. So, pareha ra sila dagway sa double tube ang triple tube. So, mao to siya ang three different types of core barrel. So, let's move on to the cone penetration test. So, cone penetration test or CPT is an invasive soil test that defines soil strata, type, soil properties, and strength parameters. It is highly repeatable, intensive to operators, and best suited for uncemented soil, sands, clay, although this test retrieves no sample for laboratory testing or visual inspection. So, in figure 2.19, mo ni siya ang cone penetration test process. So, i-inject ang cone pile sa equipment aron iyahaning i-compress down to the ground. So mo ni siya ang dagway. Siya process gyud, mo ni siya process ni cone penetration test. So let's move on to the field vane shear test. The shear vane test is a method of measuring the undrained shear strength of cohesive soil. The test carried out with equipment consisting of a rod with vanes mounted to that is inserted into the ground and rotated. So sa vane shear test, kung mag-measure ka sa undrained shear strength, magamit siya og equipment consisting of a rod vanes mounted to that inserted into the ground and rotated. So ituyok siya. So mo ni ang figure sa vane shear test, BST. So na siya rod, then ay mura og plate nga gi welding, dayon i-push siya to the bottom of borehole, dayon ayha na siya gamitan og torque meter katong equipment nga para motuyok. So mo ni siya ang mga steps or process sa vane shear test. So let's move on to the pressure meter test. Is an in situ testing method used to determine the stress strain response of the tested soil. The pressure meter test, also known as the Minyard pressure meter (MPM) test, it is performed by applying pressure to the sidewalls of a borehole and recording the corresponding deformation. So mao ni siya ang figure sa pressure meter test or PMT. So temporary casting, pressure meter probe, and pre-bore hole. So pasok siya sa borehole, then drill rod lower probe into pre-bore hole and expand with pressurized water. So para makuan siya, kanang expand siya, gamitan siya og pressurized water. So magamit agapon og equipment. So screw pump, each full rotation of this piston cylinder forces an incremental volume of water or gas or oil into the PMT probe. Measure corresponding pressure at each increment. So ang screw pump mo ni nagdala og pressure para ang pressure meter probe mo kuan pa siya, ma-expand pa siya ayo dito sa ilalom. So rubber membrane of the probe expands as a right cylinder. Evaluate per cylindrical cavity expansion theory. Plot pressure versus volume change or delta B or alternatively volumetric strain or cavity strain to find the pressure meter parameters. So mao ni siya ang process or dagway sa pressure meter test. So let's move on to the dilatometer test or DMT. DMT is an in situ testing method used to determine the strength and deformation of characteristics of fine-grained soils. This method involves a stainless blade shaped probe with thin circular steel membrane mounted on one side. The blade has a cutting edge to penetrate the soil and is inserted into the ground at a desired depth. So let's see the figure 2.25. This is a calibration for flat plate dilatometer. So gamitan siya og mga liquid or gas para naay pressure. Okay, ano siya ang lagway sa or process sa dilatometer pressure, dilatometer testing. So let's move on to California bearing test or CBR. California bearing ratio or CBR test is a penetration test in which standard piston having an area of 3 inches squared is used to penetrate a potential road bed or road base soil sample. The soil sample is first compacted using standard Proctor compaction test at the optimum moisture content and soaked for a specified period to simulate critical weight conditions. A surcharge load is applied on the compact soil sample to simulate the in situ stress due to pavement structure. See the table 2.12. The standard penetration rate is 0.05 inches per minute and the pressure value at each is 0.1 inch. Penetration is recorded up to 0.5 inches. Results from a typical test are illustrated in figure 2.29. So, let's see the table 2.10, comparison and approximate cost involved with SPT, CPT, and dilatometer testing. So, sa test na SPT, CPT, and DMT. So, ang cost sa SPT is $10 to $20. Ang CPT is nag-cost siya og $9 to $15. Ang DMT is nag-cost siya og $30 to $85. Ang unit niya per linear feet. Reharas latanan, fill linear feet. Then ang mobilization is nag-cost og $150 to $300 and CPT is $300 and the DMT is $150 to $300. Okay, let's see the figure 2.28 CBR testing equipment. Letter A, schematic diagram CBR test apparatus, and letter B, CBR compression tester. So letter A, sample contained in a mold with a soil charge weights on a top. So the size of mold, the height is 177.8 mm in 7 inches, and the width of mold is 152.4 mm or 6 inches, and the diameter of penetration piston is 49.6 mm or 1.95 inches. And the letter B is the pictures of CBR compression test. So, muna siya ang compression test, dagway niya. So, let's see the table 2.13 illustration of determination of CBR. So, displacement inches unit 0.1 and 0.2. Stress PSI 78 and 135. CBR is 7.8 and 9. So normal lateral pressure allowing time for consolidation, then slowly pulling the plates until shearing occurs. The shearing force is progressively increased until the soil fails. The point of failure identified by the peak reading on the shear stress hydraulic gauge. This maximum shear stress is then plotted with the corresponding normal stress to produce a point on the typical mohair column failure envelope. By repeating the same procedure with different normal stresses, a series of different failure conditions can be obtained. Then, as in the case of direct shear test, the shear stress versus normal stress plot can be paired with the mohair column failure envelope to obtain the cohesion and friction angle of the tested soil. So, mato siya ang CBR test or California bearing test. So, let's move on to the borehole shear test, BST. Borehole shear test is Borehole shear test or BST can be adapted to rapidly measure the soil shear strength parameters of fine to medium grain soils in situ. The BST analogous to a laboratory direct shear test or simple shear test with a pre-drainage. Hence, the shear strength parameters obtained consolidate drain once. The most common BST technique used is the Iowa borehole shear test apparatus. See the figure 2.30. So the figure 2.30, the Iowa borehole shear test BST, showing the pressure source and instrumentation console, pulling the device and the expanded shear head on the sides of the borehole. So pulling device, sa pulling device na siya ay worm gear sa ibabaw, then sa ground level na siya ay hydraulic gauge or meter. Then sa gas lines maniagyanan sa gas to pressure the shear head. Then sa pipe lines na siya pressure gauge or metrosan. Then pressure regulator na apod. So diri na siya, under na siya sa console. Then para na siya pressure, gamitan siya og bottled gas. So mao din siya dagway sa Iowa borehole shear test. So makita diri ang process niya sa borehole shear test. So the advantages of the BST are as follows. The BST is used to conduct in situ measurements of soil strength, precluding any sampling disturbance to the soil. Number 2 is the BST enables the cohesion and friction angle to the evaluated separately. And number 3, data obtained from BST can be plotted and assessed on site, allowing for the repetition if the results are found to be unreasonable or erroneous based on quality checking.